lecture, we discuss on inference rule. So inference rule plays a fundamental role in logic, mathematics, and computer science. It provides a systematic way to draw valid conclusion based on given premise or statement. So inference rule are essential tool for formal reasoning, allowing us to make logical deduction and solve complex problems. So now let's start with the basic terminologies of inference rules. So basic terminologies of inference rule is a premise, conclusion, arguments, and valid arguments. So premise. Premise is a statement or proposition. Everyone knows what is the proposition. Proposition is any statement that having a true result, true or false. Okay, but not both. That is called as a proposition. Here, premise is a statement or proposition that serve as evidence or a reason in an argument. That is called a premise. Or you can say another word, premise is a starting point of an argument. It's called as a premise. Okay, see here, this is the example. If it is raining, so this is your premise. Then ground will be wet. It's your conclusion. Okay, now next term, basic term is a conclusion. We already understand, I think, what is a conclusion. The conclusion is a statement that is inferred or deduced from the given premise using a logical reasoning or inference rule. Same example here, it is a raining, so the ground is wet. So the ground is wet is your conclusion. Okay. So next terminology is a argument. So what is meant by argument? Argument consists of one or more premise and conclusion. Argument having a one or more premise and conclusion. The premise are the proposition assumed to be true, and conclusion is a statement that claim to follow from the premise. Here, in argument having a one or more premise, maybe more than one or two premise also, we assume that here, this is your first premise. If it is raining, it's your first premise, then ground will be wet. And second premise, it is raining, and conclusion, the ground is wet. So your first premise is what? If it is raining, then ground will be wet. That means we can write here P implies Q, and second premise is your P. It is raining, and your conclusion become a the ground is wet. We again see in our inference rule, modus ponens rule. Okay, so we move on next slide. Before going to next slide, we again see the one concept that is valid argument. If your premise is true, your conclusion become a true. This type of proposition is called as a valid argument. Okay, an argument consists of one or more premises. Okay, so now we move on a next slide. Next slide, start with the type of inference rule. So this is your first type, modus ponens. Modus ponens, or we can say law of detachment. Here two premises are there, P, and P implies Q. P is, it is just snowing. It's your first premise, and second premise is what? P implies Q. If P then Q, that means if it is snowing, then I will study discrete math. And your conclusion become a Q, that is I will study discrete math. Using the truth table, if your two premises P implies Q is true, P is true, your Q become a true. This corresponding tautology P, and if P then Q, then Q. Okay, so we move on to next slide. Next rule is a modus tollens rule. Here again two premises are there. In this rule. Okay. So first premise is a negation Q. P implies Q. Your conclusion become a negation P. Okay. So your first premise is what? If I will not study discrete math. We assume that is your first premise. I will not study discrete math. The second premise is that if it is raining, then I will study discrete math. Okay, but here you declared you will not study discrete math. Obviously, your conclusion become what? It is not snowing. It is not snowing. It's your conclusion. Corresponding tautology, negation Q, and if P then Q, then negation P. Okay. So next rule, that is hypothetical syllogism. Hypothetical syllogism having a two premise again. If P then Q, if Q then R, your conclusion become a if P then R. Now we take an example here. Same example. P, it's snow. Q, I will study discrete math. R, I will get A. So our premise is what? If it is snow, then I will study discrete math. If I study discrete math, I will get A. What will be the conclusion here? P, yes, it is, if it is snow, I will get A. Okay. So therefore, if it's snow, I will get an A. It's your conclusion according to hypothetical syllogism. Or hypothetical syllogism also called as a chain argument. Next rule is disjunction syllogism. And disjunction syllogism, or we can say or elimination. Here two premises P or Q and negation P. Using same examples, you'll get the conclusion is a Q. So what will be the Q? I will study English literature. Here there are different premises. P means what? I will study discrete math. We use the or connective here. Use the or connective because here disjunctive syllogism, or you can say or elimination. Okay. So P or Q, we use or connective. P, I will study discrete math, and Q, I will study English literature. So your first premise is I will study discrete math or I will study English literature. When I will not study discrete math, your conclusion become I will study English literature. Okay. Your corresponding tautology P or Q and negation P implies Q. Or you can say if P or Q and negation P, then Q. Now move on to next slide. And the next slide is again another rule of inference addition. Or you can say disjunction introduction. Here we having a one premise and conclusion. Okay. Corresponding tautology. If P, then P or Q. Your P is I will study discrete math. Q is I will visit in Las Vegas. So if we take a premise, I will study discrete math. So your conclusion become I will study discrete math or I will visit Las Vegas. Next inference rule, simplification, or you can say conjunction elimination. Same here, one premise and you get the conclusion here. We use and connective. Corresponding tautology. If P and Q, then P. Here I'll study discrete math. Q, I'll study English literature. Your premise, I'll study discrete math and English literature. Obviously, your conclusion become a there, I will study discrete math. So next, Inference rule is a conjunction. Here, conjunction having two premise P and Q. We use the and connective here, corresponding tautology. Function P and function Q implies P and Q. So P, I'll study discrete math, I'll study English literature. So your conclusion become I'll study discrete math and I'll study English literature, because here we use which operator? Is and operator. Okay. We combine these two premises using and operator. Okay. So after that, we see the resolution inference rule. This is very important rule. It is a resolution inference rule. And this rule plays an important role in artificial intelligence and is used the programming language Prolog also. Here we are using two premises P or Q, negation P or R. And your conclusion become a Q or R. See here, the A, I will study discrete math, I will study database, I will study English literature. Okay, so here these three premises. So here, according to this three statement, premise is that first premise is what? P or Q. That means I will study discrete math or I will study database. Second premise, I will not study discrete math or I will study English literature. So here, your conclusion become I will study database or I will English literature. Okay, this is your conclusion. So next lecture, we see other rules of inference. Okay, so now we stop here. Thank you, students.